Assalamualaikum and greeting to all lecturers. My name is Mohd Najmi bin Mohd Rashdan. I have been supervised by Dr. Muhammad Faizal bin Hasan. Today, I want to present my final year project. The title for my final year project is Torrefaction of palm kernel shell and petcoke blends with various temperatures. Throughout this presentation, I will cover on 5 topics, which introduction, literature review, methodology, result and discussion, and conclusion. First and foremost, the introduction. Let me give you exposure about what is biomass. Biomass is one of renewable energy in Malaysia. Malaysia is the world leading exporter of palm oil, exporting more than 19.9 million tons of palm oil in 2017. The extraction of palm oil from farm fruit results in large quantity of waste in the form of palm kernel shell, empty fruit bunch, and mesocoque fiber. For the biomass, there are several weaknesses of biomass characteristics. These include low heating value, high moisture content, low energy density, and low gradability. Characteristic for produce solid biofuel is torrefaction process. Torrefaction is thermochemical treatment process for carbonaceous feedstock just as biomass. It takes place under atmospheric condition and within a temperature range of approximately 230 to 300 degrees Celsius. There are two dominant factors for torrefaction process, which is various temperatures for torrefaction process and residence time for torrefaction process. In this project, there are few problem statements that have been listed, which are higher demand of energy source, biomass characteristic, and redundant of all palm biomass and petcoke blends. The main objective for this project is to evaluate the performance of palm kernel shell and petcoke blends after torrefaction for various temperatures. For the scope of study, the temperature is varied from 250 to 300 degrees Celsius, residence time fixed 30 minutes, and the performance of torrefied palm kernel shell and petcoke is evaluated in terms of mass yield, energy yield, gross calorific value, moisture content, volatile matter, ash content, and fixed carbon. For literature review, I will select a sum of journal. My first journal is Pre-treatment of palm kernel shell by torrefaction for co-gasification. This study describes the effect of pre-treatment on palm kernel shell by torrefaction for the possibility of co-gasification. In this experiment, they use a PKS as a sample and torrefied at a various temperature, that is 210, 250, and 290 for the 60-minute holding time with nitrogen fluoride. From this experiment, they are study that reveal that the solid conversion and calorific value increase as the torrefaction temperature increase. That also a mass yield and energy yield decrease as the torrefaction temperature increase. For my second journal, title is Study of Effect of Temperature and Residence Time on Calorific Study of Effect of Temperature and Residence Time on Calorific Value of Torrefied Biomass. The goal of research was to study the effect of residence time and temperature on torrefaction process alone. In this experiment, the parameter used is a various temperature, that is 210, 240, and 270 at 15, 30, and 45 minute residence time for each temperature. After completion of the research, it was found that the torrefaction process increased the heating value of unprocessed biomass. Torrefaction at a temperature 270 and 50-minute residence time was concluded to be the most suitable condition for the heating value. For my third journal, the title is Torrefaction of Malaysian palm kernel shell into value-added solid fuel. The concept of study towards torrefaction of PKS was performed under various temperature and residence time. For parameter used in this experiment, that is PKS is being grinded into a small particle size, that is 250 micrometer. There are 9 sets of different torrefaction conditions that are used in the experiment, that is temperature 240, 260, 280, and then 30, 60, and 90 minutes for residence time. In this experiment, the torrefaction significantly improved the properties of PKS. The experimental and the analysis result showed that the mass energy and the mass and energy yield of torrefied PKS decreased with the increase of torrefaction temperature and residence time. So we move to the other chapter. This is methodology. This is my flowchart for doing the experiment. This is the equipment that I use for the for sample preparation, there's a grinding machine, roller mixing, and shift shaker. For the combustion properties, I divide by 2, that is calorific value, and proximate analysis. In this experiment, the calorific value for the raw sample and torrefied product need to measure. The equipment that I use to measure the calorific value, that is bomb calorimeter. In proximate analysis, we measure moisture content, volatile matter, ash content, and fixed carbon. For moisture content, we set up the temperature to 107 plus minus 3 degrees Celsius, duration for 1 hour, and we use ASTM D3173. For the volatile matter, the setup temperature is 950 plus minus 200 degrees Celsius, duration time of 7 minutes, and we use ASTM D3175. For the ash content, the started temperature is 750 degrees Celsius, duration for 4 hours, and we use ASTM D374. This is diagram for experiment setup for torrefaction experiment. The parameter used in the experiment is nitrogen flow rate 1 liter per minute, heating rate 5 degrees Celsius per minute, torrefaction temperature 250, 275, and 300 degrees Celsius. For the residence time, there is a fixed, that is 30 minutes. For this result, this is proximate analysis for PKS and Petcoke before torrefaction process. The table shows the value of the moisture content, volatile matter, ash content, and fixed carbon before torrefaction. We move to result and discussion. First is physical properties, that is appearance. The physical appearance can be determined by observing the color change on the sample. Based on the appearance, the color of sample change from brownish to darker color. From this appearance, we can conclude that the higher the temperature, the darker the torrefied sample. Okay, we move for the second physical properties, that is mass loss. As we can see from the graph, the trend is increase. From the experiment, the mass loss will increase due to the temperature increase. The temperature will affect the mass loss in the biomass sample. Based on the previous study, the mass loss is due to vaporization of moisture content due to the hydration process which occur at a temperature below 105 degrees Celsius. After that, physical properties for mass yield. As we can see at the graph, the trend is different with the mass loss. For the average mass yield of PKS and Petcoke again torrefaction temperature, there's a decrease. From the experiment, the mass yield showed the mass yield decrease as the torrefaction temperature increase. This is due to the breakdown of hemicellulose and cellulose at lignin. According to the study, the decrease in moisture content and volatile matter content leads to the decrease in mass yield from Jaffa and Ahmad 2011. For the physical properties, energy yield, based on the graph, the average energy yield decreased as the temperature increased. This decrease is due to the mass yield decrease and the calorific value increase. As we can see at the equation, the mass yield and the calorific value effect of the value for energy yield. Okay, we move for the others analysis, that is combustion properties for the calorific value. Based on the result, it shows that the calorific value is directly proportional to the torrefaction temperature. The higher the temperature, the higher the calorific value. The calorific value increase due to the increase in the carbon content in the sample and moisture content decrease at the highest temperature. Okay, we go to the other combustion properties, that is proximate analysis. In the proximate analysis, we are analysis for four conditions, that is moisture content, volatile matter, ash content, and fixed carbon. Based on the graph, we can see that the moisture content and volatile decrease at the temperature decrease. The moisture content reduced due to the dehydrated of sample at the highest temperature. Second, for the ash content and fixed carbon. As we can see, the ash content and fixed carbon increase at the temperature increase. For the fixed carbon content and calorific value have a significant effect to the fuel properties. The higher the carbon, the higher calorific value. In conclusion, For the physical properties, the mass loss increase when the torrefaction temperature increase. The energy yield is decreased when the temperature increase. For the combustion properties, calorific value increase as the temperature increase. Based on the result, calorific value fulfill the requirements stated by DIN 51731. For the proximate analysis, the moisture content and the volatile matter decrease as the torrefaction temperature increase. In addition, the ash content and the fixed carbon content increase as the temperature increase. From all the results, we can conclude that the presence of petcoke in torrefaction give the impact to the vertical and the combustion properties in biomass. The increase of torrefaction temperature was affected the physical and the combustion properties in biomass. For future study, the different composition of palm kernel shell and petcoke blend can be conducted for the future study. Second one is the torrefaction with different mixture of sample can be conducted. The last one is the pre-treatment also can be added on the future study to reduce the ash content. This is my Gantt chart for PSM1 and this is my Gantt chart for PSM2. This is my list of reference. That's all from me. Thank you.